Hi, today we're going to go over the ACT128PC. This is the little brother to the ACT128SA and SAT and can be used as an extension to those models, giving you more nodes. But it can be used with a PC, Windows 11, as a standalone test system. The software works the same way and looks very similar. I guess the big difference is the file system, as it works with the disk and the USB on the PC. So let's start by first testing a cable. Select your adapter cards and place them on the unit. Then attach your cable. Connect the PC to the laptop using a standard USB cable that's provided. And start your software. Try to get to the best view here. The first thing we have to do is select our adapter cards. The first one is a COM2F female. It has a DB50 female on it. The second was a COM2 male, and it has a DB50 male on it. Now the next thing we got to do is load a reference on there. This is whatever our cable is going to be compared to. There's two different ways of doing it. One is to use the load reference, and it'll come up and you can search for your cable that you've saved recently. Or in this case, we're going to learn our reference from the cable that's plugged in. So we're going to simply press learn. The next thing we're going to want to do is verify that this is the cable and it is correct. So we're going to enter schematics, and you can zoom in, zoom out. You can pull on the connector, move them around, whatever you want to do. But as you notice, this cable has all 50 pins connected. I am a little surprised that the shield's not connected on this cable, but I assume that's what this is. We can also look into the wire list, which will give us a line by line. Pin 1 on side A is connected to pin 1 on side B, pin 2 to pin 2, 3 to 3, all the way down, and you can scroll all the way down to all your connections. Then there is a pin list that you can look at. Now this is referenced to the board, and the board has 128 nodes on it. So this could actually, if you're going to end up being a harness or something like that, you may want to reference back to this. This tells you where every pin is connected to every pin on the other side. And there is a net list you can look at. So you have unit 1, side A, pin 1 is connected to unit 1, side B, pin 1. And that goes all the way down. So we've verified this cable. We now have a good reference. Okay, the first thing we're going to want to do is we're going to want to test this reference to another cable. So we're going to go in here and go into single mode. We can press start. and it matches. Next we can come in and we can go into Auto, Stop on Failure, press Start, and we'll keep testing it until you get a failure. Now I'm going to pull this cable loose over here. And it stopped. And you can go down, look through your compare list here. You'll see where things started messing up down here. With this X in here, showing you that pin, that was the first pin to disconnect, and then it stopped. The next thing you can do is go in here to continuous mode, and now this will run forever. And I'm going to make it fail by pulling this connector out. And we'll plug it back in, and it's passing again. Now we're going to move into the cable assembly modes, peak and poke. Peak works great when you have a cable that you have completed half of it and you want to connect it straight through. So using the same adapter, let's change to a connector on a DB9M, and I'm going to plug in this little DB9 connector with 3 wires on it. These wires happen to be hooked up to pins 3, 7, and 9. Okay, so I did move a couple of connectors around, so we're going to have to change number 1 to the COM2M, and DB9M is the pin we're going to be looking at. The second one doesn't matter. However, you can have connect two boards simultaneously running on here and be looking at the different pins on each board. So what's going to happen here is I'm going to touch a pin to the probe pin that's on the board, and it will show us where that pin is connected to. So I'm going to simply go up here to start. Now here's a case where you might want to turn the volume down. Okay, I'm going to hook the first pin up. Okay, it's telling me I'm hooked up to pin 7. I'm going to hook the second pin up. It's going to tell me it's hooked up to pin 9. I'm going to hook up the third pin, and it's going to tell me it's connected to pin 3. So if you're building a straight through cable, you can plug them right in. If you want to, you can of course use a schematics or whatever and cross them here, but there's an easier way. Now let's assume you have a cable that you want to make into a crossover or some other configuration. This is where poke comes in handy. This works like peak, but allows you to set up your own database and simply let the ACT128 tell you where to poke the wire. Okay, I'm going to use the same adapter board and connector. Then I'm going to enter the poke file manager. Adapters, poke file manager. And the first thing I'm going to have to do is choose the adapter. These are critical. So this is a COM2M board that I'm using. Then the connector is a DB9. Of course, all the connectors are on here. And then I'm going to have to give it a name. So we're going to call it DB9, DB9 to DB25. Okay, so we have a name, we have the adapter, we have our connector, that we'll be plugging in. The part number and the comments are optional. So I know that I only have pins 3, 7, and 9 hooked up. So I'm going to say we're going to hook up pin 3, and it's going to go to we're going to tell it to poke into pin 4. Okay, pin 7, we're going to tell it to poke into pin 6. Why not? And then the shield, we're going to tell it to, we're going to take pin 9 and tell it to hook up to the shield. And now we have our little poke file all set up. Next, we want to save the poke file. Okay, then we're going to exit. If you wanted to export that file off to something else, to another unit, you would simply use the export feature. So we're going to exit. That's all set up. We're going to switch over here to poke. And notice that a new line comes in here, poke file. And there's a couple of them. There's one I did before. This is the one I just did. So that is now our poke file. And it works simply like this. Tell it to start. And I'm going to hook up. It's telling me I'm hooked up to pin 7, and it goes to pin 6. This tells me I'm hooked up to pin 3, and it's supposed to be poked into pin 4. And this tells me I'm hooked up to pin 9, and I'm supposed to hook that to the shield. Now, you can do more than one pin if you want to on here. For instance, this is what happens. I got 4, 6, and shield by tapping all 3 onto the probe pin. And that, in a nutshell, is the poke mode. Now let's assume you're going to build your own adapter using one of these. This is our You Build It board, and it has all 64 pins going around, your own connector on there, and then you run wires out to it. The first thing we do is the adapter manager. We're going to enter a new adapter. Now, if you notice, you can come up here and you can look at all the adapters that are existing out there right now. Those aren't what we want. We're going to enter a new adapter. And we're going to call it Mill 22. And we're going to add a connector. We're going to call that circular. I like the capital letters here. It's not necessary. We'll call it circular 22. And press enter. Now we're going to add a pin. First, we're going to have to select the connector. Notice you can keep adding connectors over here. And then when you're ready, you go select your connector and you add a pin. Now the pin name can be any alphanumeric that you want to put in there. I'm going to call it pin A. And we're going to connect that to pin 1. Next one, we're going to add another pin. It's going to be pin B. And we're going to connect that to 2. And the next one will be pin C. We're going to connect that to 3. So let's call this our connector. This is the whole thing. We're going to save it. And then we can also export it at this point if we want to. But at this point, we're going to exit. We can go up here. We can go Mill 22. And we're picking this CIR 22 connector. we're going to do a learn on it. Now, I don't have a cable hooked on here. So here's what the schematic's going to look like. Here's our CIR22, A, B, and C. On the second side, on B side, I didn't change the connector, so here's our DB9 still over there. And there's no connections because there are none. Now, if you want to delete that connector, let's say we don't like the CIR22, we go over here, go back into the adapters, adapter manager, we type in L22, and we tell it delete adapter, yes, and that adapter is now gone. Okay, I'm going to quickly go over some of these options. These are actually covered on the other video for the ACT128 SA and SAT, but I just want to cover them here too. On the options page, you have a user's manual, which gives you detail about everything. At the top, you have a table of contents line, and it allows you to pick what you want to look at. Go into testing. We have cable assembly, which is the poke and peek mode. Now also notice we have a volume control down here. It's turned pretty much down, but it's not all the way down. Also here we have a keyboard on and off. This is what allows the on-screen keyboard to come up. If it's turned on, the on-screen keyboard will come up. If it's turned off, you can use your local keyboard on your laptop. I personally like the on-screen keyboard because that means I don't have to even take my hand off the mouse. One more item on the ACT128 is on the bottom. Let's see if we get this in so you can see it. There's a hole here where there's a switch inside for setting up its unit number. This one happens to be set up as unit 1, but it's important that they are set up so that you don't have multiple units with the same number. And that's something you can take a little tip of a knife or something like that and flip these switches. Be kind of careful with those. The ACT128SA and the SAT are set as unit 0. So if you use this as an extension, you want to set it to something other than 0. Thank you for watching. For more information, check out our website at advice1.com, http://advice1.com. Thank you very much.